The first delta H ionization and the second ionization energies and the electron gain enthalpies of few elements are given below. Lovely, I am given some data. Okay. Which of the above elements is likely to be A, the least reactive element? Now, when we are talking about electron gain enthalpy, you should feel happy while gaining electrons, right? Even alkali metals, the very donor ones also, they feel okay. They release some energy if you give them electrons. All negative. Now, this is ugly because do you see that you have to really push in energy. You're giving electron, that is big deal itself, and you also have to supply energy. And not just withstanding that, they have an insanely high value of ionization energy as well. So they have worst ionization energies. That means it is very difficult to take electrons away from them, and they have very poor electron affinity. That means they don't even like accepting electrons. This is ridiculous. Now you don't want to accept electrons, you don't want to give electrons, then what do you want? You want to do nothing. Yes, they are saying we want to do nothing. So that means the least reactive is 5. They are very seemingly noble gases or something of that kind. 5 appears to be the stupidest of all, and yes, it is. B part, the most reactive metal. Now they are talking about metal. Metals are likely to have very less ionization energies. The less ionization energies are these and these. And the least is this. You see that? So we have nothing to do with electron affinities simply because we don't expect them to be having good electron affinities. Metals are not happy accepting electrons. And anyway, these three are poor ones, so they are a kind of proof that these are metals. They have low ionization energies and they also have low electron affinities, so albeit exothermic. Most reactive of these metals seems to be 2. Why? 2 has lowest ionization energy. That means it can give away electrons most easily. That means it will react most happily. Makes sense for me. Fine. Most reactive non-metal is going to be something which accepts electrons very happily. Now, happiness while accepting electrons can be seen here. Now, ionization energy is high. Who cares? We are not going to ionize them anyways. So they may keep having high ionization energy. 3 happens to be a non-metal as well as 4. Both of these are non-metals. And amongst them, more energy is released by 3. That means 3 is a more reactive non-metal, most probably. Is that the only criteria? Actually, that is not the only criteria, because for that matter, electron affinity of chlorine is even greater than that of fluorine. Although fluorine happens to be more reactive. But then based on this data, this seems to be the only thing which we might be able to infer, unless we remember what are the exact values of electron affinities of F and Cl. I mean, just let's wait for a moment. Just observe this also. This has high electron affinity. This also has high ionization energy. Had this been fluorine, now fluorine would have a high ionization energy as compared to chlorine. No, and this one seems to be having less. So there is no case or no fear of exception of F and Cl here. 3 happens to be most reactive, and that makes absolute sense. Least reactive non-metal. Actually, there are only 2 non-metals. In fact, least reactive non-metal is 5. Why? 5 is a noble gas, and all noble gases are non-metals. So yes, that is the least reactive non-metal indeed. The metal which can form a stable binary halide of formula Mx2. Now they are looking for a metal which has a formula Mx2. If I look at these 3 candidates, they are metals. They are metals, right? And the other three are non-metals. So I am not even considering them. These, they are non-metals. So I am not talking about them. Fine. Amongst these 3, see, 520 is the energy which is required to remove the first electron. The second one, if you remove, it is more than even 10 times, more than 5,200 also. That means removal of second electron is very difficult. That means most probably 1 forms only +1 cations, not +2. In second case, please note 419 and 3051. This is also, if you just care to note, it's roughly 7.5 times more, 700% more, which is like very high. So this most probably 2 also is going to form +1 cations only. Why? Because removal of second electrons is like, second electron is quite difficult in case of both 1 as well as 2. If you look at 6, 738, and it is just twice. Anyway, second ionization energy must be more than first, that's okay. But it's not like 10 times or 8 times or 5 times, nothing like that. This appears more humane. That means it is losing second electron reasonably happily. So I would say that 6 would be most likely to have this formula mx2. It would also show a valency of 2 instead of 1. Metal number 1 and 2, they would have valency of 1 only. Metal number 6 will have valency of 2. The metal which can form predominantly stable covalent halide of the formula. Okay. If the metal has to form a covalent halide of formula Mx, first of all, it must have valency 1. If it has valency 1, it has to be either 1 or 2. Okay. And it can form a predominantly stable covalent halide. Now, if it has to form a covalent halide, that means it must have more polarizing power. More polarizing power means higher ionization energy. Now, 1 seems to have higher ionization energy. That means more polarizing power, also more covalent compound. So the best answer would be 1 in this case. Very instructive, beautiful question, deeply conceptual.